Welcome to The Explainer. Today, we're jumping right into one of the biggest questions there is. What exactly is the relationship between our mind and our brain? Is the part of you that thinks really separate from the physical machine that does the thinking? To get to the bottom of this, we're going to dive into a text that does something pretty cool. It mashes together two worlds that you'd think are total opposites, ancient philosophy and early modern science. So, let's get into it. All right, so to start untangling this whole mystery, our source takes us way back in time. It asks us to think about the body in a way that people did long before we ever had things like microscopes or brain scans. Now, this definition comes from an ancient Indian school of philosophy called Nyaya, and their take is fascinating. They saw the body as way more than just, flesh and bone. To them, it's the vessel for our choices, the gateway for all our senses, and basically the stage where our entire experience of the world plays out. So it's a definition based on what the body does, not just what it's made of. Okay, so hold that philosophical idea in your head because we're about to do a complete 180. The text shifts gears hard, pulling us into the much more mechanical world of early 20th century anatomy. And look at this. It's a totally different way of seeing ourselves, right? This old diagram shows the body as a physical network, almost like a set of biological wires, all connected to a central command center. The text breaks this whole network down into two main parts. First, you've got this central system. That's the main hub, the big boss, the brain and the spinal cord. Then you have the peripheral system, which is basically the massive web of nerves that connects every single part of your body back to that central hub. So how is this command center organized? Well, the source points to neuroscience pioneers like Sherrington. And this quote here reveals something that was a total game changer. The brain isn't just one giant processor. Turns out, different senses, like sight or sound or touch, they each have their own dedicated separate highway coming into the brain. And get this, the idea of separation gets even more specific. The text brings up another scientist, G.F. Stout, who showed that the part of our brain that controls movement is basically a physical map of the body. There are specific little spots dedicated to controlling your toes, your fingers, even your jaw. It's like a detailed schematic of you, hardwired right into your brain. So we have this command center, and we have this incredibly detailed map. But how does the control center actually talk to the rest of the body to make things happen? It all comes down to a two-way communication superhighway. You've got afferent nerves. Think of these as the messengers, carrying all the sensory info from the body up to the brain. And then you have the efferent nerves. These are the movers, carrying the commands from the brain out to the body to get it to do something. The text gives us a perfect, really simple example of this. Imagine you touch something hot with your foot. Instantly, step one, those afferent nerves fire off a hot signal all the way to your central nervous system. Step two, the brain gets it and immediately identifies it as danger. Step three, a move command shoots back down through the efferent nerves. And step four, your leg muscles get the message and you yank your foot away. That entire circuit fires in a fraction of a second. Now, to help us wrap our heads around all this complexity, the source uses this really powerful analogy. It compares the brain to a post office. All the incoming sensory information is like mail getting sorted into different departments. And then the outgoing commands are like packages being sent to the exact body part that needs them. It's a beautifully simple way to visualize something so incredibly complex. All right, let's pull all this together in our final section, because this is where it all comes to a head. This is where the philosophy and the biology really collide. So, here's the crucial point. After walking us through all of the physical mechanics, the text leaves us with two distinct things. On one side, you have the mind, the thing that actually thinks, right? The seat of your consciousness. And on the other side, you have the brain, the physical tool for thinking, the biological machine that does all the processing. The thinker and the thinking machine. And this is the profound, mind-bending question the text leaves us with. If the mind that decides to do something and the brain that carries it out are really two separate and independent things, then how in the world do they work together so perfectly, so seamlessly? Where does a thought stop and an electrical signal begin? It's a mystery that connects those ancient philosophical questions with modern science, and it's one we still haven't fully solved.